So there's obviously a big difference between inductive and deductive reasoning.
Mm-hmm.
I think maybe a simple example of that is that deduction is true by definition. But abduction seems like it's not true until certain conditions, like there's an assumption first, and then the truth is built off of that assumption.
Yeah, I mean, abduction, I think, is this kind of thing, the truth of which it remains perpetually deferred. As you're saying, deduction being true by definition is in that sense sort of as certain as can be, let's say. Induction, you get more confidence proportionate to the number of instances. Abduction is like an educated guess, and being an educated guess, the evidence in favor of the guess can obviously increase, but ultimately there are other ways of explanatorily accounting for what the guess aims to account for, and therefore, especially if some of the new data didn't fit with the educated guess, similar to induction, but induction usually involves a kind of a modification of the existing rule, not a complete reformulation, whereas abduction would be, if you get evidence that diverges dramatically from what you would expect to see, and then maybe the whole explanation is wrong and we need to come up with a new educated guess. And a lot of science actually consists in abductive inferences that are then borne out by sort of deductive and inductive evaluations of the observable data.
Right. And there's even abductive claims that are still just kind of lingering in science that haven't got models that really accurately give us the details. For example, like quantum gravity is a phrase that in the claiming of it assumes that there's something to unite relativity in quantum mechanics, as opposed to there being something new which might make this obviously not accurate in some way.